Thanks for the invitation.
Sure. You are our first speaker, sir. So we'll be having a round of talks, 2 more rounds after your, and then we'll take a moderated panel discussion. Dr. Alka is also with us, and she will be overseeing the process.
Yeah, nice.
So looking forward, we have 2 more minutes, sir. I will start sharp at 9.
Sounds good.
Dr. Alka, should we start? Yeah. Good morning, Dr. Alka. Good to see you. You are muted. You are muted. Still can't hear you.
Yeah. Can't hear either.
Probably the microphone is not connected, or the speaker of the system, microphone of the system is not working, something like that. Maybe if you jack up a headphone, and it will be easier to. Vishak has shared the C20 backdrop. In case any of our speakers wants to use that, it's on the chat. Thank you, Vishak.
Hello.
Yes, there you are. There you are.
Oh, perfect. Thank you so much. Okay.
Should we start now, ma'am?
Yes, please.
Okay.
Thank you, Devashish, for accepting to moderate the talk.
Thank you so much, ma'am. It's an honor. Such a brilliant line of speakers. It's an honor. Thank you so much. Om Amriteshwarya Namaha. My humble salutations and pranams to our C20 Chair Amma, Her Holiness Mata Amritanandamai Devi, and my wholehearted greetings and a warm welcome to all the distinguished personalities, scholars present here. On behalf of the C20 India Working Group on Sustainable and Resilient Communities, Climate, Environment, and Net Zero Targets, I, Debashish Brahma, welcome you all to this webinar on water governance and environmental sustainability. The Sustainable and Resilient Communities Working Group is one of the 14 under the C20 India 2023 and focuses on the thematic areas of climate resilience, social justice, environmental sustainability, net zero emission targets, and compassion-driven approaches to sustainable and resilient communities. The working group is coordinated by Dr. Manisha Sudhir, India coordinator from Amrita Vishwavidyapeetham University here, and Professor Vinod Menon, who's going to join us shortly, who's the international coordinator and regional director of Asia TIEMS Oslo and Brussels. Dr. Ati Shivan, who's the international coordinator, chairman, is the chairman of the Amriteshwari Foundation in Malaysia. Through knowledge sharing, multilateral and international engagements, and raising awareness amongst the CSOs, policy influencers, academicians, public policymakers, and the youth, we look forward to achieving the C20 India vision. You are the light. As a part of the working group, we are here to explore pathways to build resilience in a changing climate. Building climate resilience involves a range of strategies, collaborations, actions, improving infrastructure, land use planning, diversifying livelihoods, enhancing social safety nets, strengthening ecosystems, and also promoting adaptive governance. These actions reduce vulnerability and enhance adaptive capacity while providing core benefits like food security, health, and biodiversity conservation. In that note, I take this moment to welcome the extremely glittery round of distinguished guests who are present with us. We'll be hearing them one after the other. We have Dr. Alireza Faramand, who's the Assistant Professor of Environmental Science at California State University, USA. We have Dr. Kumar Gaurav, who's the Assistant Professor in the Department of Earth and Environmental Sciences at IISER at Bhopal. And we also have Crispino Lobo, who's the co-founder and managing trustee of Watershed Organization Trust in India. So all in all, a very packed morning, evening, and afternoon for some of you. But before we progress on that, let us first invoke the blessings of the divine through a prayer.
ध्यायामो धवलावगुण्डनवती तेजोमयीं नैष्टिकीं स्निग्धापाङ्गविलोकिनीं भगवतीं मन्दस्मितश्रीमुखीं वात्सल्यामृतवर्षिणीं सुमधुरं सङ्कीर्तनालापिनीं श्यामाङ्कीं मधुसिक्तसूक्तिम् अमृतानन्दात्मिकाम् ईश्वरी.
Thank you so much. And on that note, may I take this opportunity first to welcome Dr. Alka. Dr. Alka Singh currently serves as an assistant professor at the Amrita Vishwavidyapeetham at its Amritapuri campus in Kerala. And she has done a postdoc from the NASA Jet Propulsion Laboratory and the Goddard Space Flight Center. She obtained her PhD from TU Munich, Germany, and master's from ITC Netherlands and the Indian Institute of Remote Sensing at Dehradun. Welcome you, Dr. Alka. We are so glad we have your presence as the academic moderator for this session, and invite your interventions wherever you find relevant and adequate.
Thank you, Devesh.
Thank you, ma'am. Now let's move on to the first speaker of the session today, Dr. Alireza Faramand. Dr. Ali Reza is an assistant professor at the Environmental Science at California State University in Los Angeles. Previously, he was the postdoctoral scholar and a data science engineer at NASA's Jet Propulsion Laboratory. While continuing his affiliation with NASA JPL, Dr. Faramand is currently the science lead for NASA AIRS Drought application system, which has been incorporated into the US Drought Monitor, the USDM assessment procedure since 2017. He's also the faculty coordinator of the Environmental Science MS program at Cal State at LA. His main research interests include utilizing remote sensing observations along with statistical approaches and GIS techniques for developing more reliable models for hydrological systems given the climatic changes and the anthropogenic activities. These include hydroclimatic extremes like drought, wildfires, landslides, and their impact on water resource management, agriculture, and vegetation health. He is graduated with a PhD in water resources engineering from University of California, Irvine in 2016. He is actively collaborating with stakeholders to ensure that his research can be integrated into the operational applications and is a previous awardee of the National Science Foundation Technology Transfer Entrepreneurial Lead Scholarship. Thank you so much, Dr. Ali Reza Farmud, for joining with us today. I invite you to deliver your speech for the scheduled time. Then we take up some highly relevant questions, and then we take up the bulk of the questions later in the moderation after all our speakers finished. On that note, sir, apology for intervention. I take the opportunity to invite all the speakers who have joined us currently, Crispino Lobo, Dr. Vishwanathan, and Dr. Kumar Gaurav also. And now let's join our hands to hear from Dr. Ali Reza. Over to you, sir.
Yeah, sure. Thank you very much. It's my pleasure to be here. And especially thanks to Alka, my colleague and friend, for inviting me. So it's my pleasure.
Thanks for joining, Ali.
Yeah, sure. Okay, let me share my PowerPoint slides. Okay. All right, so I'm going to talk about a topic called From Hydroclimate Research to Applications, Integrating a Drought Monitoring Index into the USDM, US Drought Monitor Framework. So I'm going to start talking about the topic of drought monitoring. So historically, we've been using a lot of ground-based observations to monitor and detect droughts, these kind of observations provide very valuable climate information, such as precipitation or soil moisture, etc. But they have several limitations, including uneven distribution of gauges, temporal and spatial inconsistencies, lack of observations in remote regions. So therefore, satellite-based products have become very popular for monitoring and detecting a variety of extremes, including droughts. So I've been very interested in early drought detection, which is very important in several sectors, including water and agriculture. For example, water managers can use the early drought detection for water resource planning. Farmers could purchase less fertilizers and increase their insurance coverage before the growing season if they're aware of an upcoming drought. So usually and generally, precipitation is most commonly used for monitoring drought onset or the beginning of drought. But research from myself and my colleagues have shown that near surface air relative humidity, temperature, and vapor pressure deficit, or VPD, from the NASA EARS mission have the potential to detect drought earlier than precipitation. And I'm going to talk about this very briefly. So first of all, what is the EARS mission? So NASA EARS mission stands for Atmospheric Infrared Sounder, which is on board of NASA's Aqua satellite. So this mission was launched in 2002, or more than 20 years ago, with the goal of supporting climate research and improve weather forecasting. And it is expected to end its orbit around in 2025. It measures infrared radiances, mainly brightness temperatures emitted from Earth's surface. There's around 2,400 detectors to mainly create profiles of Earth temperature and water vapor. So it has a polar orbit with minimum of 2 overpasses per day. And then there's a global coverage of 16 days with a 45-kilometer resolution. And so with the purpose of drought monitoring, the strength of Earth's data is that they are direct observations. So meaning that the data going into a calculation of air relative humidity or temperature and VPD, these are not model derived, for example, such as evapotranspiration or ET. And so we show in a couple of papers back in 2015 and 16. So this is one paper shows the probability of relative humidity detection compared to precipitation was around 60%, with a mean lead time of around 2 months, meaning that with around 2 months, we could detect the relative humidity up to 2 months earlier than precipitation, which was a very promising result. And also, another paper from my colleague and former supervisor showed a similar potential for vapor pressure deficit or air temperature for detecting drought onset earlier than precipitation. So for those of you who are not familiar with VPD, it's basically a climate variable which incorporates both elements of temperature and humidity, which is the difference between the amount of moisture in the air and how much moisture the air can hold when it is saturated. So I'd like to move on from the science to now talk about, after we showcase these strength of these 3 indicators for detecting drought onset, we thought about how can we put this into applications. So therefore, we contacted the agency called U.S. Drought Monitor. And so this agency is managed by National Drought Mitigation Center, is located in University of Nebraska Lincoln in the USA. And they produce weekly maps of drought, like something you can see here. This is the most recent one. So they produce weekly maps which shows the areas of drought, or everything in reddish colors. The more red means that more intense droughts, and the white regions means that the normal conditions. And so this is derived using several variables, including drought indicators, vegetation information, hydrologic and water indices, remote sensing, and ground validation. But something interesting from this map is that it not only derives inputs from objective indicators, like whatever I just talked about here, but also it takes the input from experts, subjective inputs, such as state climatologists, National Weather Service staff, and hydrologists. So these are experts in the field that the authors of these maps, so-called authors, they talk to these people and they combine the input from them with these data, the objective inputs, to come up with these maps manually, which makes this somehow kind of a unique type of monitoring. And how is this map used? It's actually used as like the guideline for drought monitoring by a variety of agencies and policymakers. So they use this to help to determine drought relief allocations and declarations of drought. It's widely used in academic research, informing decision makers and policy experts. It aids in declaration of disasters, as well as economic assistance to agricultural communities, as well as also wildfire danger assessment. So you can see that it has a broad applications, which is used by a variety of agencies and stakeholders. So after our discussions with the EARS, with the U.S. Drought Monitor, so they became interested in our products and they wanted to potentially use it for their operational framework. And so, and we were also very, of course, happy about this incident. So therefore, we have been delivering the near surface quantities as percentiles to US Drought Monitor since 2017. And we deliver all quantities, including relative humidity, air temperature, and also vapor pressure deficit, and also in 4 different time scales. So each of these indicators are built at a 7-day, weekly, a 14-day, a 28-day, which is almost monthly, and a 56-day, which is 2 months. So together, we deliver 12 maps every single week for relative humidity, temperature, and vapor pressure deficit. And you can see one example here. So this is a VPD products from the end of month of January of 2022. This is the 7-day average. This is a 14-day average. This is the 28-day average, and this is the 56-day average. And we had a flash drought event back in 2019 in the Southeast, and you can see what the EARS products VPD shows and what the actual USDM map shows. And if you look at the Southeast in September 2019, we were able to potentially detect this the drought almost a month before the actual event that USDM maps show. So whenever we want to talk about using satellite data, we have to think about continuity. So most of the satellites end at some point. And EARS instrument actually has been a very successful mission. It has been orbiting Earth for more than 20 years, but it will expected to cease operations in 2025 because of the lack of fuel, not about something from the instrument failure. But fortunately, there are other satellites already orbiting Earth, which they have delivering similar capability. These are called the Cross-Track Infrared Sounder, the CRISS mission, Advanced Technology Microwave Sounder, or ATMS. These are on board of the satellite called JPSS, Joint Polar Satellite System, and they provide similar the atmospheric temperature and pressure and the moisture profiles. So we have been talking about providing the continuous drought data using the CRISS and ATMS data, but we're having plans we are not considering, but they are not yet in place. But we are very hopeful that we can continue generating these drought products using these new missions. So for the last part, I'd like to actually talk about a training, which is I think it's interesting. So after this couple of years that we've been providing these products to the US Drought Monitor, which is in 2017, almost 5 years, so we decided to provide a training to the authors for multiple purposes. First of all, to provide them with best practices using the EARS data, and also survey them with questions that will allow us to determine, or the EARS project will determine the next steps. So the questions such as, are you using these products right now? Do you understand how to use the products? Or do you actually find any value? Or do you have any suggestions to improve our products? So after so I'm not going to talk about the details of the best practices. So we provided a number of case studies that how these data can be used for drought early detection. But something interesting was that we actually administered a brief survey immediately after our training, which was aimed to help the effectiveness of our training and also determine the next steps, and also how much time is needed before a longer survey. So the idea was that after a period of time that the authors have had the opportunity to use the products, we will contact them again to participate in a long survey, and also to determine if our training was helpful and how we can improve the products and other products from NASA. And so right now we have not administered the longer survey yet, but we did administer the brief survey, which I want to talk about what results did we get. I think was interesting. So these are some of the questions that we asked right after the training, such as what is your main area of interest, such as are you more from the agriculture community, from vegetation community, from forecasting or monitoring. So how often do you use the products right now, and how likely are you going to use the products from now on, that after you have heard about this training? So one other thing was that which products are more useful to you, so under what circumstances are you most likely to use the products? We also asked if are you interested in indicators in other timescales, and also how long do you need time to use the products before you are ready to participate in a long survey. So these were the questions that we came up with after a lot of brainstorming with the team, that these were the most appropriate questions that we wanted to ask. And we actually received very interesting feedback that we kind of, some of them kind of unexpected. So for example, we realized that most of the authors never or only sometimes use the products, but after the training, they were either likely or very likely to use them in the future, which was a very encouraging result. And we also realized they were very interested in the VPD products, more than relative humidity and temperature. And we realized that they're interested in using the products for flash drought monitoring, which is a type of drought that develops very rapidly, for drought onset detection and drought early warning. We also realized that the authors are interested in some of the timescales that we actually do not provide, such as 3-day, 6-week, 3-month, and 6-month. We also realized that they need time, they need at least 6-month time to test and work with the data before participating in the long survey. And lastly, we also discovered that they're actually interested in generating products for our US territories, such as Puerto Rico and US Virgin Islands. And we had a number of very encouraging comments on the usefulness of the training, such as JPL could have the market cornered of these products, or these are unique tools that USTM don't have right now, and JPL had set the bar high for effective training. So all of these were kind of a thank you note to us, and we were very relieved after we heard, because we spent a lot of time in preparing the workshop and kind of training for the authors. And lastly, so I want to conclude with some of the conclusions that we received after the survey. Was that training is really critical for increasing the usability of data, and also it may have a significant impact on the future strategic and technical development of our products. So we've been talking about how better and what future avenues we're thinking about right now. So it takes a team, really a lot of people, to create the training materials. So as I said, we spent a lot of time. We were a group of people that we came up with these materials. And we also realized having a partner was really highly beneficial to determining what matters to the stakeholders, receiving feedback about the materials, and facilitating communication with all USDM authors. And right now we are investigating the improvements suggested by the authors. We also have been working on other research ideas. I've been trying to work with my students and also other colleagues to think about what research we can also do about this data. We will administer a survey to authors very soon to get their feedback about potential future suggested improvements. And lastly, we are also working on building an algorithm for data continuity by combining data from Earth and the other satellites, as mentioned before, such as CRIS, ATMS, so that we can have this nice transition after the mission ends in a couple of years. And yeah, that was my last slide. Thank you.
Thank you, sir. Thank you very much. I was just trying to look at if there are any concurrent topics for discussion in the chat and Q&A. Dr. Alka, is there anything important that you want to take it up right now as a discussion? You're muted.
Devashish, can you quickly introduce sir? So we have
yes, of course. We have Dr. Sudesh K. Vadhavan sir with us, who's the adjunct professor at Amrita Vishwavidyapitham at the Amrita Puri campus here in Kerala. He's the former Director General of the Geological Survey of India. Indeed, such a great honor to have you with us today.
Thank you very much. My quick observation and question. Thank you very much, Dr. Alireza. It was excellent, very insightful presentation. But I was just looking for some of the mitigation measures. Drought monitoring and predicting is one aspect. But how do you suggest to mitigate wherever you see that these are the areas which are frequently affected by the droughts?
Well, yeah, that's a good question. So when you talk about the mitigation, we're going to talk about impacts, right? So how droughts are impacting the agriculture community, the vegetation health, the sustainability. Well, can you maybe elaborate on what kind of, are you referring to like agriculture or these kind of mitigation efforts? What are you referring to in terms of drought?
Regarding water security, availability of water for domestic purposes and also for maybe for some agricultural activities. So
yeah, so the idea behind this early drought detection was actually, one idea was that if you, as I mentioned in the slide, if there is enough information about early drought detection, it could actually be very helpful in terms of water resource planning or everything related to the mitigation efforts, or for agriculture community. So they could be very helpful in terms of their purposes, what to plant, where to plant, and when to plant. So what kind of fertilizer they use. I myself talked to a lot of farmers back when I was a PhD student and when this work started. And I realized that so even 1 month of information about the drought forecasting or early drought detection could very much help them in terms of their management scenarios. So that's why the idea of transitioning from research or applications came from this, that how can we not only talk about the research and how can we make it into applications or kind of full mitigation. Yeah.
Okay, thank you very much. I think we'll discuss more during our panel discussions. Thank you.
Okay.
Alireza, it is interesting to see the transition in your research also, that you have incorporated the survey part of it and now also into the application side. I was wondering, this training you did, it was like online or there was some workshop organized? And is it just for authors or also like stakeholders? How was it?
What was your second question?
So who were the your trainees?
Oh, the audience. Okay, yeah. It was online first of all, and so we had one of the authors. He was Brian Fuchs, so he was our point of contact, and and then so for a month we talked with him, we discussed our ideas, we even had a dry run with him, and then we invited all USDM authors. So there were 9 of them. So these are people who kind of manually, you see, there's a small name here, author Brad Repeat. So So there are like 9 authors that they rotate every week to kind of draw these maps. As I said, they're kind of manual type of maps. And we invite all of them. There were 9 of them, and they were the people who attended this the training. And we have been also thinking about actually providing a training to the extended community of other stakeholders. But this one was primarily for the author of these maps.
Can we do it in India?
Yeah, we can. Can we expand it to like international platform as well, or is it confined to, because the monitoring is actually done for only US, I guess, right?
Yeah, so this is a US agency, and they only provide maps for United States. So these are not generated for
Global.
global applications. But what we have been providing with the Earth data, so these are the satellite data, as you know, we work with them. So we are very interested to maybe work with other communities, other international communities or stakeholders to see if there are enough interest.
Yeah, so we can think of combining some your expertise here and maybe expand.
We'll be happy to collaborate with you and your organization to work more, particularly in Indian conditions.
Yeah, and there may be even interest from NASA side, or maybe NASA is also interested in working with you guys. I think that's fantastic myself.
Yeah,
Yeah.
let's look into the possibilities.
Yeah, I mean, I've been very excited about kind of operationalizing some of the research and see how they can be integrated into applications. Yeah.
Like we used to discuss this, that whatever we do doesn't translate into land. Now, if we can really translate something into real problem solving, that will be some contribution to the community.
Right. Exactly, Alka. I remember our discussions, and I mean, I strongly believe that there's this major gap. So we're doing a lot of these research, but we never get into application. We just write them papers and publish them. But what happens next? And if there's also actually a big push from NASA headquarters to how can we use NASA data for applications, not only fundamental research, but also the applications. But yeah, of course, I would really love to discuss this with you guys. Yeah,
we'll continue our discussion later. Back to you, Debashish.
Thank you, Dr. Alka. Thank you, Dr. Alireza. Let's move on to the next speaker for the session today, Dr. Kumar Gaurav. Dr. Kumar Gaurav is an assistant professor in the Department of Earth and Environmental Sciences at IISER at Bhopal. He has done his PhD in fluvial geomorphology from the Institut de Physique des Globes de Paris at France. He has done MSc in geoinformatics jointly from the Indian Institute of Remote Sensing at Dehradun and ITC in Netherlands. Dr. Gaurav is interested in learning the dynamics and morphology of rivers, effect of drainage congestion on flood inundation, and application of remote sensing to monitor soil moisture and stream flow. His work combines mathematical theory, physical reasoning, field observations, and digital image analysis to recognize the necessary ingredients to model them. Indeed, an honor, sir, to have you with us, Dr. Kumar Gaurav, and I invite you for your session now.
Thanks, Devashish, and I thank you all from the organizing committee members. So am I audible?
Yeah, thank you, Gaurav.
So let me share my screen and do let me know if you can see my screen. Can you see my slides?
Yeah.
Is it visible? Yeah. So now it is in full screen mode. Yeah, so let's start. So again, thank you very much for inviting me for this talk. And I know that this is about the water governance and environmental sustainability. So being a scientist, I think the way I think water governance cannot be done until unless we understand water. We understand the availability of water, where it is, what are the potential aquifer, what are the source of water available in Earth for our use. So to target this, I'll discuss with you about a river which has flown once upon a time in the western Himalayan foreland, which is known as Punjab Haryana plains. So the title of my talk is a glimpse of flow in the lost Saraswati River. So just let me give you a brief about the Saraswati River. So here I have in 4 panels, you see different figures. In the first figure is the location where Saraswati used to flow. So now you can see here a small drainage which is named as Ghaggar. So this is supposed to be the oldest course of the lost Saraswati River, which has flown in this plain. And if you see present day satellite image, so what you can see here is a linear feature, and which has channel width about 5 to 6 kilometers that one can observe. And then people started thinking about what this paleochannel represents, from where it comes, how much flow it used to carry, what kind of river it was. To answer these questions, I'll use satellite and hydrogeomorphic approach to estimate how much flow could have flown through this river. So just to give you the geomorphology of this area, as you can see here, the Ghaggar River, and then you have Satluj River, you have Yamuna River, and in between that, you have Yamuna fan and the Satluj fan. And you know that these alluvial fans are the considerable resources for the water, for the aquifer. And so the last panel it shows the groundwater depletion. So as you can see here in present day, this region has depleted, the groundwater level has depleted a lot. So as you can see here, the maximum depletion is about 30 meters. So the first thing here, some river has flown, and this region is a potential groundwater aquifer. Okay, so now to go further and give you a brief about the Saraswati River, from where it comes. So in Vedic literature, we have description about the Saraswati River that comes from the Rig Veda. As you can see here, so according to Rig Veda, so this is the greatest of all rivers. So, and in Nadinam Ashurya, you see that the river was most powerful. The Nadinam Suchi, it says that the river was the purest river, and Nadi Tame means the best river. So this represents, if one can think in terms of dimension of this river and how sacred this river was. So if the most power means the river must used to carry a lot of discharge, okay, and the river used to flow with the purest water. Now, it's not about the description of Saraswati River in terms of magnitude that we can understand, but also from the Vedic literature, we can get some idea about its location, where this Saraswati River was located. So as you can see here, there is a sloka in Nadistuti in Rig Veda. It says that, so the Ganga, Yamuna, Saraswati, Satudri. So if you try to understand its position, so it is between Yamuna and Satluj. So as you can see here, Ganga comes first, then Yamuna, Saraswati, and Satudri, which is present day known as Satluj. So this river Saraswati has flown somewhere between Yamuna and Satudri. So this is the location and position of river from the Vedic literature. So now if you see, it's not only the Rig Veda. So the description of Saraswati River is also followed in Brahmanas and Mahabharata, Yajurveda. So in each, so for example, in early hymn of Rig Veda, it says that the Himalayan stream with 6 major tributaries. So this is the description of Saraswati River was given in Rig Veda. Means the river used to flow independently into Arabian Sea. And then in later hymns of Rig Veda, it says that the Saraswati lost much of its glory, and the word Sapta Saraswati began to be substituted with the Sapta Sindhu, means Indus with its 6 major tributaries. That means the now river started to lose its flow. And then Yajurveda, it says the river changed to Panchanadia, means earlier it was 6 tributaries, now river has narrowed down again only with the 5 channels. And in Brahmanas, if you see the description of Saraswati River, it says that river disappears at a place called Vinasana. And if you see this, and the source of this Vinasana is also documented, that is called Plaksh Pravarshana. So that means the literal meaning of that is the giant fig tree. Plaksa. In Mahabharata, this location is located somewhere in the Sivalik hill that is documented. So these are the chronologies that we know about the Rig Veda, about the Saraswati River in different ancient literature of India. So this was all about the ancient literature. So then people in modern days, scientists started learning about this river, and James Rennell in 1788, first he mapped this river Saraswati in his memoir of a map of Hindustan. Later on, Lavavien de Saint Martin, a French scholar in 1860, he suggested that this dry river bed occupied by Ghaggar River must be the relict of Saraswati River described in the Vedic hymns. And later, followed by this, there are many important papers that you can find in the literature. So I'll not go into those literatures. Now, I'll show this the oldest map which was prepared by C.F. Oldham in 1704. As you can see here, he has mapped Yamuna, and then this Chitang or Dristavati, which is the old paleochannel of Yamuna River, and then you have Ghaggar River and Naiwal, which is known as the Satluj paleochannel, this is how he mapped. Now, Oldham argued that the Ghaggar River with its source in the non-glacial Sivalik could not have provided the large perennial discharge of the Saraswati description in Rig Veda, and the Satluj used to maintain the valley through several southwest early courses known as Nahiwal, some of which he mapped in his map that I discussed just now. He also argued that Yamuna used to contribute to the Saraswati River through the Chitang Nala, which he considered as Dristavati River of Rig Veda and the Mahabharata. Finally, he concluded that Saraswati became decimated when the Satluj shifted away from the Ghaggar-Hakra Valley to join the Beas River. So now, according to C.D. Oldham, what he said that it's not only the Ghaggar River alone it used to flow, because Ghaggar originates from Sivalik. So to have a perennial discharge, of that kind, you must have some Himalayan source. And what he, according to him, the Satluj River and Yamuna River used to feed Ghaggar River, and jointly they used to flow together to form Saraswati River. So now, by using this analogy, we have created three different hypotheses. Okay, so this hypothesis says that first in scenario 1, which is pre-LGM, it says that all Satluj, Ghaggar and Yamuna River used to flow together. Ghaggar and Satluj used to join Ghaggar River at Shatrana, and Yamuna used to join this Ghaggar River at Suratgarh. Later on, in scenario 2, to 20K to 8K, what happened is this Yamuna River disappeared, as you can see here, and only Satluj and Ghaggar used to flow, and perhaps a small portion of Yamuna also used to flow, that we don't know much. And in third scenario is the avulsion of both Yamuna River. So Yamuna River gets dried up, Satluj took a shift, and now what you have is the remnant of Saraswati River there, where you have just flow from the Ghaggar River, and presently this river is ephemeral river. Okay, so this is how Saraswati, Yamuna and Satluj migrated from the Saraswati River, and Saraswati River disappeared. These are the three different hypotheses. So now, based on these three hypotheses, there is a link of civilization. So how river disappearance affected the civilization also. So as you can see here, this map on the left is the first stage, the early Harappan phase. So as you can see here, along this Dristavati River, there are many Harappan sites one can see. So many of these Harappan sites disappeared in the second stage of matured Harappan phase. As you can see here, the density of these points, Harappan sites, disappeared. And finally, if you see along this in the third stage, so all these Harappan sites is migrated upward, and you hardly see any Harappan site in the lower reaches. Okay, so this means the river shifting is also impact the civilization. Now the question is, the main question is, okay, so if Saraswati River was flowing according to the Veda, it has to be a large river. So how in present day, how we understand large river, how we define large river? So large rivers can be defined according to Potter 1978 and Tandon Sinha 2007, based on the catchment area, sediment and water discharge. So usually the large river system, you usually have higher catchment, larger catchment area, higher sediment and water discharge, channel dimension, width and length. As you can see, Ganga in the downstream. So you have high catchment and the width also, width of the river. Sedimentary archive and preserved ancient delta. So these are the by which we can define whether a river can be considered as a large river or not. But in case of paleochannels, this catchment area, sediment and water discharge, channel dimension, these parameters are difficult to obtain. So how we can indirectly estimate those things? Okay, so there we have a concept of hydraulic geometry that says that channel dimension is proportional to discharge with some exponent, and generally in theoretically we know that this exponent is, most of the river is close to, theoretically we know that it's 0.5. This is a theoretical value. And similarly, discharge and width is also depends upon the catchment area, and that exponent ranges between 0.2 to 1.01. This value coming from the empirical measurements. Okay, so that means higher the catchment area, higher will be the discharge and eventually width. And these are some empirical studies that has been reported. And as you can see here, the exponent value varies in this range. Now, so empirical relation between the catchment area to the width and discharge of the river can be established. So now we can think of establishing. So now what we have is the satellite image, as you can see here, and here we have just the paleochannel. And this is known to us from the satellite image. We can measure this paleochannel width, and that is something around 5 to 8 kilometers. And this is the known thing that we have, and that can be used for validation purpose. And then the catchment area. So the catchment area we can calculate by using our hypothesis, considering the individual catchment of all these channels, Satluj, Yamuna, and Ghaggar. Unknown to us is what we don't know, the discharge, and that we can estimate by using these known parameters. Now the very important thing, this width, the channel width, which has 5 to 8 kilometers, what this represents, we don't know whether. So from geomorphology, the width can be defined in different ways. You can have valley width, channel belt width, and channel width. Okay, so as you can see here, how channel width, valley width, and channel belt width can be defined. So based on this, since this in satellite image, what we see is the moisture width. So therefore, this cannot be considered as a channel width. Neither this can be considered as a channel belt width, valley width. So what it can be considered as channel width. So we have considered channel width. We have assumed this as a channel width, and based on this width, channel belt width, we have developed different empirical relationship. And for catchment area, from the hypothesis, we have considered the catchment area for Satluj individually, Yamuna, and Ghaggar. So now we know the catchment area at a given location for all these rivers. Now, so if you see that for the Himalayan river, so this is coming from one of my papers. So this is the black line represents the theoretical value, and this is where Himalayan river fits. So as you can see here, about 5 order of discharges, all the behavior of Himalayan river, the width of the Himalayan river behave in a similar way as a function of discharge. Means we can say that wherever, it doesn't matter wherever you are on the Himalayan plain, you go measure width and you can estimate discharge by using this relationship. If this is true, so to go ahead, what we have done, we have extracted width, okay, throughout the Himalayan plain. As you can see here, we have samples from the Indus plain, Ganga plain, Brahmaputra plain, and we have measured their catchment area and corresponding width, channel belt width. So this is how we use satellite temporal satellite images to measure the channel belt width. And these are the assumptions that we consider while considering a reach for the measurement of channel belt width. And then the other important parameter that we need is the discharge, because we have to establish width discharge relationship and catchment area discharge relationship. So discharge is tricky because we cannot get discharge for the paleochannels. Okay, so for the modern river, even so, in case of river, it's not only the instantaneous discharge, not the maximum discharge that sets the geometry of river. So to set the geometry of river, the discharge we are interested in is the formative discharge that has a capacity to form a channel. Okay, And that discharge in Himalayan river can be considered as the annual average discharge. So we have considered the annual average discharge for all the modern rivers. And then once we have all the data sets, we have plotted channel belt width as a function of catchment area. And as you can see here, for all the Indus Basin, Ganga Basin, Brahmaputra Basin, they are all, they fall along a single line. Okay, they cannot be, it appears that they cannot be differentiated. So all they behave in a similar way. Similarly, discharge catchment area, as you can see here, for all the Indus Basin, Ganga Basin, and Brahmaputra Basin, they cannot be differentiated. For that, we have done a statistical test, which is to test whether Indus Basin, Ganga Basin, and Brahmaputra Basin, they are different or they are same. So we found that all they are same. Now, once you have, then we fit a curve. So channel belt width as a function of catchment area, discharge as a function of catchment area, and we got exponent value 0.41 in case of channel width and catchment area, and discharge catchment area we got 0.77. And this value, as you can see here, this value accords well with the previous finding. So we are within that range. So our value is also matches with the previous findings. Now, once we have that, so now what we can do is we can predict the width of Saraswati River. How? So this is the rating curve that we have, channel belt as a function of catchment area. And what we know is the catchment area we can guess. So considering our scenario 1, scenario 2, scenario 3. So we have considered scenario 1 where the Ghaggar, Satluj, Yamuna, all they used to flow together. So if you add at the downstream of Suratgarh, Ghaggar, Yamuna, and Satluj, so and the catchment area, that gives you width of about 11 kilometers. Similarly, in the downstream of Satrana, because Yamuna River joins for the downstream, so what you have is only Ghaggar and Satrana. So that gives you 7 kilometers. So by this way, we can estimate, we can get some estimate of width at different scenario, for different scenarios, scenario 1, scenario 2, scenario 3. Now, as you can see here, so we have compared our results with the previous finding, and as you can see here, in our case, we have the width that we are getting at the confluence of Ghaggar and Satluj is 7 kilometers, and at the confluence of Ghaggar, Yamuna, and Satluj is about 11 kilometers, and that is in accordance with the previous finding, that is based on the subsurface geology and also based on the satellite images. Now, in a similar way, we go and now compute, because we know the catchment area discharge relationship that we have. So similarly, we have for the catchment area, what could be the discharge? We can add the catchment area of Ghaggar, Yamuna, and Satluj, and then we can get the indirect estimate of discharge by using this rating curve. So this is how we have computed discharge and channel width. And channel width we have validated also with the finding, previous finding, and then we proceed for the discharge estimation. This is how we have estimated discharge. Now, if you go and compare, okay, so how this Saraswati River compares, discharge of Saraswati River compares with the modern day discharge of the river, Himalayan River. So as you can see here, I have discharge data hydrographs from Indus River at Kotri Barrage, Chenab, Punjab, Ganga River at Farakka, Kosi River, Bhimnagar Barrage, Brahmaputra, Bahadrabad, and Ganga, Pakshe in Bangladesh. So this is the mean discharge. This straight dotted line represents the mean discharge. And as you can see here, the Indus River at Kotri Barrage, mean discharge is about 4,000, Chenab 2,500, and Kosi 15, approximately 1,600. So now, according to scenario 1, the combined discharge of Yamuna, Ghaggar, Satluj at the downstream of Suratgarh is the order of 3,000 cubic meter per second. And if you compare that, that is probably the kind of discharge that Indus flows at Kotri Barrage, okay, and the Chenab River at Punjab. So that discharge is comparable. Now, just to conclude, what we can say that is a simple hydrogeomorphic approach based on the rating curve relationship and using from satellite images and topographic map is we can explain the width of the Saraswati River observed on the satellite images and provide a first order estimate of average annual discharge. And consider, and this be informed that this is considering the present day hydraulics. We don't know the hydraulics of Saraswati River in its ancient time, assuming that the all the Himalayan river behaves in a similar way. So we have considered the present day hydraulic condition of the Himalayan river to say something about the hydraulics of the North Saraswati River. So this is how I conclude this study. Thank you very much. If you have any question.
Thank you so much, Dr. Gaurav. Dr. Alka, is there any important topic you want to take up right now?
Yeah, okay. Thank you very much, Dr. Gaurav. Very informative. A lot of scientific data that you presented. We certainly will request you to please share your publication reprints with us because we also are quite keen to work in this particular area, Saraswati. Now, my small query is, of course, chronologically, a lot of OSL dating has also been done on some of these sediments. So we also have some regard of dating of some of the events. For example, when the Yamuna River migrated, when that new tectonic activity took place and all that. Because from PRL, I know some good publications are there on this aspect of dating. My query to you is was the Saraswati River a glacial origin river? Was it getting a lot of glacial water melt inputs, or was it essentially based on the rainfall inputs? Because a lot of climatic change impacts are also involved in this. And second is, how best can we revive some of these old paleochannels to conserve groundwater? Because this area is aridity affected. And, if we can somehow preserve our water availability, maybe also through Indra Canal, into these paleochannels, then we can save a lot of evaporation losses that happen in this area. So what are your views on this, please?
Yeah, so thank you very much, sir. So one by one, I'll answer your questions. So the first question is whether this river had a glaciated origin or not. So answer to me is a school of thought, some group of people, based on their evidence and data, they think that it has a glaciated origin. So for example, recently the paper in 2017, a paper was published in Nature Communication by a group of PRL and Rajiv Sinha from IIT Kanpur. They have done Jirkan analysis to estimate. They have basically done the Jirkan analysis of sediment sample, and based on that, they say that it has glaciated origin also. Another thing is very important at the climate of that time. Yes, there is some scientists, they believe that because that time the rainfall used to be much higher than what we receive today. So there must be some rainfall input also. But to have a perennial river, as we know that it's not only the monsoon water that is responsible for discharge throughout in the Himalayan system. Because monsoon, you get only 2 to 3 months of monsoons. Okay, that is not sufficient. It's the glacier and also the groundwater that is responsible for a continuous flow in the Himalayan system. If I answer this first two questions, then the third question, as you rightly said, that this area is a water stressed region. In my first slide, this was my objective to show what was the condition at one point of time. This is a region where you have 2 alluvial fans, which is supposed to have a considerable reservoir and good aquifer that holds. And now, because of the irrigation and all those things, we are extracting huge amount of water, and that is water is depleted about 30 meters in some regions. Yes. So if you see recent slide, I don't have that video, but I have seen somewhere last year there was a flood in this Ghaggar River, and you won't believe that the water was flowing like anything. The flow velocity must have been 4 to 5 meters per second, and discharge comparable to 3,000 of that order, I'm saying. Okay, so there is a potential that if we can rejuvenate that channel, okay, so that will help us not only to recharge the aquifer and also to minimize the water losses. Okay, because all the water will infiltrate, because you have already aquifer. So those aquifer, if we can again rebuild.
Revive. Yeah, we can revive those. Yeah, thank you very much. But then, further downstream, the Hakra and Nara channels, they are still there, and they are also need to be, part of the Saraswati
exactly.
channel. Yeah.
Exactly.
Okay, right. Thank you very much. Maybe we'll discuss more during
Sure.
our time.
Sure.
Thank you very much.
This paper is published in Paleo 3. I'll share this manuscript with you.
Okay, thank you. That will be great.
Thank you very much, sir.
Yeah. So, Gaurav, I was wondering when you were saying the Panchanadya, you in some scriptures like old ancient scriptures, so you were referring to Indus, isn't it?
Yeah, so it says that how the because when now we also know that, for example, Ganga in the downstream reaches Ganga, it's not one channel. So Ganga, there are many tributaries that joins Ganga. Okay, for example, Bhagirathi and all those things we know. So similarly, they say in the beginning there was 7th river, altogether they were joining, then one river disappeared, 6th river, then later on one more disappeared, then 5, and eventually later on it disappeared.
Yeah. So all these were draining into Indus and then finally into Arabian Sea.
They were draining into the Saraswati River, not into Indus River.
Oh, you are saying that Saraswati was the main
Yeah, this
catchment.
is yeah.
So then, thinking in that line, you are saying that catchment area of Saraswati included that much.
Yeah, so the
Entire, matlab, all 5 rivers which are still present today, that used to be a catchment of Saraswati.
yeah, so though from modern day science, what people believe that it's the 3 catchments. You may have different rivers also, but it's mainly 3 catchments: Satluj, Yamuna, and Ghaggar. So Yamuna used to join Saraswati also, and Satluj these days Satluj joins Indus, but earlier Satluj used to feed Saraswati River.
And like you said, okay, these are 3 catchments which were combined together to drain into Saraswati. Then these 3 catchments have their, I mean, almost we kind of imagine that similarly we have aquifers downstairs. I mean, underground. So if we have aquifers which are like aquifers will not change as drainage pattern and surface changes. So, considering this, do we have studies already which have identified the aquifers of Satluj?
Yeah, there are many studies.
Saraswati, sorry.
Yeah, there are many studies which has been conducted on to understand the groundwater availability in that region, and also you will be surprised because in Thar desert mainly you get saline water, and people have found some freshwater patches along the river.
In Thar. So I'm
Yeah.
wondering because when we do groundwater analysis, we actually do we work in a catchment. So right now, if we are working on Yamuna catchment, and we are doing entire analysis based on the DEM, basically based on DEM only we define catchment, and so from the surface we are defining the groundwater flow, but underneath there is totally different story. Then are we doing it? Are we calculating wrong for all other catchments as well, or how is this?
Yeah, so I don't think we are using catchment to understand the groundwater. Mainly in this case, for example, I have used catchment just to understand the surface water
Yeah,
drainage.
surface water is
And
there.
in case of groundwater, also people use catchment just to define the boundary. Okay.
Right.
And then
Right.
there is a mass balance that people use to understand the groundwater.
There are different ways to achieve the groundwater modeling, but still the boundaries are defined by the surface catchment, which is from DEM, and which is currently different than way back. If we had this 3 different catchment styles, so probably there is a need to see how these underneath aquifers changed over time, or did they change, or did they are
So in case of river, what you see in an alluvial fan, basically it's a sedimentary deposit. Okay, so river deposit its sediments. It's a cyclic process. And then you have a thick aquifer. So aquifer is an accumulation of sediment of different grain sizes. So if you have a sand body, okay, if you have a gravel body, that what we can see that this aquifer has a potential to store water, and that we need, because the rainfall water that is these are unconfined aquifer. The rainfall water which comes, that has a potential. So you have a great space to hold that water. because you have high porosity and permeability, and that makes these aquifer potential aquifer for groundwater.
Mhm. Okay, we'll continue discussing and all this. Maybe continue to next presentation right now would be good. So Debashish, can you please continue?
Thanks,
Thank you.
Alka. Thanks, Devasis.
Thank you, sir. Thank you, Dr. Alka. Let's invite the next speaker of the session now, Crispino Lobo. He has over 30 years of engagement in tackling water challenges, environmental degradation, and the impacts of climate change on agriculture and livelihoods in rain-fed and dryland regions in India and internationally. He has co-founded 4 non-profits, one of which is the Watershed Organization Trust, the WOTR, which collectively has impacted the lives of over 5.16 million people in 10 states in India, trained over 676,000 people from 27 states and 63 countries, and supported development works in over 5,700 villages. He was the program coordinator of the large-scale and successful bilateral Indo-German watershed development program, the IGWDP, in Maharashtra, and has been a member of several advisory committees to government at both the state and federal levels. He has contributed to setting up 2 large national-level public funds to promote watershed development and climate change adaptation in the country. Sir has authored, co-authored, helmed around 12 books, besides several articles, chapters published in national and international journals, magazines, and books. The latest tool book is the Water Governance Standard for Water, Everybody's Business. Currently, he serves as member of the multi-stakeholder platform on water governance set up by the government of Maharashtra. And he's here. In fact, the topic is already there, quenching rural India's thirst. Crispino Lobo, sir, a very warm welcome from our team here. And I invite you on the floor for your session.
Thank you very much. Can everyone see my screen?
Yes, sir.
Okay. So I'm going to be sharing with you all some practical approaches and experience in this on this whole issue of water governance, which includes, of course, 2 components, both the supply side or augmentation of water stocks, as well as the demand side or the use side of water. A brief introduction to who we are. We are an NGO called the Watershed Organization Trust, and we have an applied research wing called the Water Center for Resilience Studies, that's WCRES. Currently, we're working in 8 states in India, and we have, of course, worked in 10 states, but we have helped and supported and accompanied over 5,700 rural communities to address their water challenges. The amount of people impacted is about 5.17 million people. So we basically organize communities to harvest rainwater wherever it falls across the landscapes, the catchments, and the watersheds they live in, and then using that to regenerate the environments and ecosystems they live in. So totally, we have got about 2.2 million hectares of land that we have worked on. And one of our major interventions is training, and so that's about 676,000 people trained to date. We work in 3 sectors. That's implementation, so we implement projects, research and policy advocacy, training, and capacity building. This is what we are basically tackling, considering that 70% of India is rain-fed, you see, and which produces about 40% of India's food and hosts most of its poor. 80% of our landmass is highly vulnerable to droughts, floods, cyclones, and climate change, and more than 30% is degraded. Worst of all is, over time, the availability of water per capita has gone down significantly, and it's expected that by 2030, India's water demand is likely to be less, much less than what's available, in fact, by half. The demand will be twice than what's available. Now, while agriculture contributes 14 to 18% of our GDP, it sustains about 58% of its people. And yet agriculture consumes 83% of our freshwater resources. It's estimated that by 2050, water scarcity will reduce GDP by 6%. Add to this the consequences of climate change, and that's costing India something. It cost us $159 billion in 2021, and it's rising. So this is the context that our organization Watershed Organization Trust, or WOTR, works in. Dryland areas where you have depleted natural resources, climate change, and often adversarial market forces, which result in fractured and vulnerable rural communities. This is the way this is our theory of change, and that's, you can increase rural communities' resilience to climate change by rejuvenating the landscapes and ecosystems they live in. Of course, at the heart of it, the connector between all these aspects is water. So increasing its availability as well as ensuring its efficient management is key, we believe, to developing our rural landscapes and our economy. Agriculture being one of the biggest sources of livelihoods in rural India, and of course, the food basket of our country, increasing agriculture productivity is vital not only for creating livelihoods, but also for ensuring food security in our country. Women hold the key, we believe in that. And we believe that strengthening local institutions in which women play a key role is important for the development both of rural area as well as the country as a whole. This will explain the kind of sectors that we are working in. All of it is anchored and built on land and water management. So that the heart of it is land and water. And we will today focus only on one aspect, which is at the bottom there, which deals with integrated watershed development, water stewardship and water governance, ecosystems and biodiversity conservation. But you can never look at water as an isolated sector, because water encompasses and permeates and influences all aspects of our lives, from economics to social life to culture to religion to everything. And so you need to look at all the other aspects of human exchange and living, which goes into making what society is all about. So we are into livelihoods, agriculture, women's empowerment, nutrition, health, and sanitation. This part that I'm now going to focus on is on augmenting water availability and stocks. Now, in rural areas, the best way of capturing as much rainwater that you can possibly harvest is by doing what we call watershed development. This gives you an example and an idea of what watershed development is. So when rain falls, it runs along the hills, collects in the rills, the streams, and the rivers, which goes into the sea, comes back as clouds, as moisture, clouds, back as precipitation and rain. This hydrological cycle is basically the water cycle. So if you want to capture rainwater wherever you are, you need to address and capture water and rain when it falls on earth, right from the ridge to the valley. So watershed development in rain-fed India is key to the development of dryland, semi-arid areas, as well as even in better water-endowed areas. What does that mean? It means that wherever rain falls, you capture it. So water that is rushing down, you make it slow. Water that is slowed down, you make it walk. Walking water, you stop it. And water that goes it underground. This is a drone shot. It gives you an idea of what is involved in real life. So you can see the top of the hill, and around it is a series of continuous contour trenches and water absorption trenches. So basically, these are barriers built on the contour lines, which are meant to arrest rushing water, reduce its velocity, reduce its erosivity. That means harvest the silt load that it is running away with, and therefore the nutrient load also, and keep water as much as possible within the catchment itself. So these are examples. These are called mechanical works, mechanical and earthen works, or area treatments. And depending on the slope of the land, the nature of the soil, the land use currently in vogue, the nature of treatments also changes. But basically, the idea is control the flow of water, slow it, stop it, force it underground. On the right side, you will see those two small vignettes. On agriculture land, cultivable land, you need to, of course, adopt different techniques because people are using this land to grow crops. So you have a series of compartment bunding. That's field bunds and compartment bundings you see on the top. A little below is the upper reaches. In the upper reaches of the catchment, along the rills and the streams, you put this series of gully plugs. These measures are basically erosion control and water harvesting, but the basic purpose of this is to reduce the velocity of water. These are snapshots of the various treatments that we do along the landscape to basically reduce the flow of water, control erosion, and harvest in situ as much water and soil as you possibly can. The idea in these treatment measures is to improve the soil moisture regime and recharge groundwater aquifers. You see, you will have noticed that I use the word often, force it underground. Because in a country like India, which is tropical, which has a monsoonic regime, where rain is only for 4 months and thereafter you have the sun, where evaporation rates can touch as much as 70% in the summer, you don't want water to be on the surface to evaporate it. You want it underground. You want it recharging groundwater aquifers, because then you can have it available throughout the year or largely through the year, but more widely available than you would otherwise have been possible. So here you have a series of continuous contour trenches across the landscapes on which you plant trees and grasses, a series of gully plugs on the beginnings of the river system or the channels, drainage system. As you go on the drainage system, the below structures are called water harvesting structures. So you have gabion structures, you have masonry structures, you have earthen gully plugs, you have stone bunds, compartment bundings. At the heart of this effort is the community. You cannot do this work in a country like India, where largely land holdings is a private regime. So where people own land, you cannot do these kind of treatments without their consent, cooperation, and full engagement. Because to do watershed development, you need to follow hydrological and engineering principles. You can't compromise on that. And measures like these continuous contour trenches do not respect human erected boundaries or barriers. They have to be following the contour line, which is a geological or a natural phenomena. So you need to then get a community engaged in doing watershed development work if you want to be successful. That's one part what I've talked about. That's harvesting, gathering, and aggregating as much water stocks as possible. But we all know that no matter how much water you get, it's never enough, because our needs grow, our ambitions grow, and our wasteful habits also expand. So managing water, the way we use it, how we use it, namely the demand side of water management, is key in a country like ours or any other country where water faces a constraint. There are various ways in which you can manage demand, but basically it comes down to change in behaviors, the way we use and perceive water, and the technologies we employ. So at the heart of it, there are 3 major ways or 4 major ways in which we try and shape management and use of water. One of them is to get rural communities to do what we call water budgeting. So by water budgeting, they basically are able to assess the net amount available to them following the rains, either before or after. And based on that, to assess what are the claims that on the available water that is there. For instance, depending on the cropping pattern you have, you can assess how much of water those crops really require to come to term. You also know that different crops have different water requirements. For instance, sugarcane consumes a lot more water than, say, dryland crops like millet. So this is a pretty well-defined science already, and we know how much of water crops require to come to full term. Animals, we know how much of water milch cattle as compared to goats require or chicken require. So based on how people are living in the village, their livelihood source, the way they earn their living, we can calculate the amount of water that is required, including for domestic needs as well as personal needs. And we try and match the amount of water available both on surface as well as in the ground, and against how much of it is required or used. Often in rain-fed India, in most parts of this country, there is a huge deficit between what is available and what is required. And you need to bridge that gap. There are various ways. One is you change your behavior patterns, for instance, the way you use water. Secondly, you change your livelihood pattern. If the cropping pattern you are adopting, for instance, is water intensive, then you switch to less water intensive crops. Another way is to adopt technology. You have drip irrigation, sprinklers, micro irrigation. So in other words, you can reduce the use of water waste by as much as 30 to 40%. You also monitor groundwater and check whether you are extracting more than what is recharged and more than what is available. You do aquifer management. You get communities to manage their groundwater. You change the way you do agriculture, for instance, because as I told you, agriculture is 83% of water consumption. So if I can use techniques in agriculture besides technology, which is water technology, the way we do agriculture, if we can reduce it, the use of water, that is a major input in reducing or improving the water use efficiency of water productivity. There'll be another slide on what we mean by agriculture, which is nature friendly and which is climate resilient. That reduces water use by as much as 20 to 30% outright. Okay, and recently we launched the water governance standard. We believe that just as the credit score brought about a huge transformation and an expansion of responsible credit in the credit sector by giving communities, rural communities in this case, a water score, we can help drive not only behaviors in terms of responsible water use behaviors, but also drive investments into the rural sector. So we've published this book, we've developed this tool called the Water Governance Standard. It's available freely on the web. Those of you who are interested can Google the Water Governance Standard, WOTR, and you'll be directed to a site. You give your email and it'll be sent to you straight, free of cost. When you organize rural communities to do water stewardship, we have found that the impact is enormous. For instance, a study in 100 villages across 2 years had these kind of impacts in terms of the way water has been used, saved, as well as made effective. We also have an app. We have developed an app. It's here it's in English, but it's also in the local language, wherein a community can assess how much water it has and how much of water it's really using and where the gap is, deficit is, and therefore what they should be doing to ensure that during summer they have enough money not only for whatever livelihoods they're doing, but also for living and drinking. One of the key, agriculture largely in India, except in areas where you have canal irrigated and assured water supply, is largely dependent on groundwater, that is well water. As much as 60 to 70% of Indian agriculture depends on groundwater. And drinking water in rural areas is as much as 85% to 95% of water for drinking comes from groundwater. In cities, you'll be surprised, as much as 60% also comes from well water. So for us, making the invisible visible, that means groundwater management, is key to our survival. This is an example. Here is a communities. We have trained communities to actually, by using satellites as well as doing geophysical investigations, we can develop a profile, not only of the surface topography or morphology of a village, but also its groundwater morphology and topography, and get a community to understand the relationship between the dynamics of surface groundwater as well as underground water, between groundwater that is there and water in use. When people understand these dynamics, and they make models, these are cardboard models, so there's a whole methodology that's available on the web. It's freely publishable. You can go on the water website and get it. They begin to understand the relationships between use and availability and groundwater dynamics. And we found that women particularly understand this a lot, because ultimately they are the providers of water for the households, and they provide most of the labor on farms. So water plays a very important role in their lives as well as their work. Another thing is water sharing. Not an easy concept, but today with technology and the fact that water is becoming scarce, more and more farmers are coming together to share water rather than spud bowels across the farmlands. Many states have dug too many wells, particularly bowels, and damage aquifers. So it's important that we get villages to use what they have well as well as share it. This is what I talked and referred to about climate smart agriculture. The more we make agriculture nature-based, low ecological footprinting, as well as the more we use nature-based solutions, the better we are placed to reduce the use of water in agriculture. So there is a series of measures and steps that can be employed, which actually makes agriculture not only environmentally friendly and water positive, but also climate resilient. These are some of the examples there. We've developed an app also called Farm Precise. It's over here, which is an Android-based app, which actually, the ambition of that is to give weather-based crop advisories to farmers on a dynamic basis, but tailored to the farm conditions of the user as well as the crop. And so the farmer has to upload his soil of farm conditions and the crop and the date of sowing, basis which then he would be given advisories customized to his farm and crop. We've got over 70,000 downloads, and it's growing. It's available in a number of languages, but eventually we hope to make it an all India possibility. It's free for farmers. Water governance standard basically is a rating and certification tool, and its purpose, as I mentioned earlier, is to help nudge responsible water management and behaviors in rural communities, to incentivize also investors to provide resources to those communities in which investments will have a greater chance of being successful and therefore are worth investing in. It also provides a comprehensive framework to track, monitor, and also highlight areas that a community needs to look at in order to ensure that the project is sustainable and equitable. And so it actually measures 4 aspects: governance and institutions, supply-side water management, demand-side water management, sustainability, and equity. And those certified are classified into 4 categories: bronze, silver, gold, and platinum, which each has its own risk profile, as well as its management pathway to enhance its sustainability and effectiveness. This is the app, Farm Precise, that I was talking about. Currently, it has 9 features. We're also going to be providing shortly advisories for livestock management, market information. It already has market information, but we're going to put a section for farmer producer companies. Currently, we've got about 28 crops, so operating in 4 states and 5 languages. We hope to expand it. If you adopt such a comprehensive approach, there are significant impacts on rural communities, apart from also water. This is an example of a village where we have done comprehensive watershed development, a dry area in Sangamne Taluka, Maharashtra. So one example, where we began work in 1996, that same spot in 2019, it's the same today, where rainfall is between 250 millimeters to 450 in good times, practically semi-arid, desert-like, and it's completely transformed. You see, overall, we have found incomes increasing by 2 to 3 times more than in those villages where such works have not been undertaken. So when you take an ecosystem-based approach, where you focus on water in terms not only of its augmentation, but in terms of its productivization, and ensure that all villagers or all households in a village benefit from it, you have not only sustainable outcomes in terms of the environment, but you also have significant economic and social impacts on households and the village community. Our studies have revealed that the benefit cost rate of return of 20 to in fact, and on poverty reduction and rural capital formation, it's significant. More important is you can see the time lapse between these 2 pictures. Even a decade and a half later, our project still goes on, managed by people. Example of a study we did, where we did the net present value analysis on an average of villages in these dryland areas, and we found that villages had an average annual income of about 1.5 lakhs. The control villages where such activities were not undertaken was only 2,000. In other words, the project villages had income levels 4 times higher than control villages, which if you turn it around would mean the cost of the way I proposed it in an integrated, comprehensive manner is actually 3 times of income that is foregone. That's the cost of inaction. So when you do it this way, involving the community, bringing in various stakeholders, adopting a holistic, integrated, and comprehensive approach, you build resilience to drought and climate change. You diversify the rural economy, and a key driver of this is role in play in this interventions. Thank you.
Thank you. Thank you, sir. Thank you very much for the wonderful presentation.
You're welcome.
With that, we have come to the. That's a wonderful picture indeed. And with that, sir, we have come to the end of the talks. I invite Dr. Alka and Professor Satish Dhawan in case, in case there are any specific discussions on this talk that you want to take, or should we open the floor for the Q&A as you would consider appropriate. Dr. Alka?
Any other questions?
It was indeed a very interesting presentation, touching different aspects, how groundwater to surface water, everything are related, and how we can do different practices. And there are many questions I am struggling to put them together, but like first thing which comes to my mind, which is like, how do you really implement when we think of all these activities? It's hard to convince a community to change their way of practices for agriculture, or so how because you have been working on field, and it seems like your area of expertise is more towards the rural water management. So I was wondering how we really convince the community to change the practice, and they have their own interests. Why will they think of, and who is going to do the budgeting? Are you working with the panchayat, the local administration, or implementing this large scale, like you showed? There were like trees and a part of field which was empty a couple of years ago, and then there were many trees. So this, like, you as a your NGO as a project took that plan and did this thing, or community did this?
Now, whatever I've shown you here has been done by the communities. We have facilitated, provided them resources, technical support, and guidance, but they have to do it. It was theirs.
Which part of India are we talking right now?
So, Maharashtra, Pradesh, Rajasthan, Jharkhand, Chhattisgarh, Odisha, and Karnataka.
Oh, many states. Then it is not an easy task to convince the community to change their way. So what is the key message we can take if we want to do the same?
Well, communities, unlike what often believed, are not hidebound. They are very pragmatic and practical people. So if you can offer them a better alternative than what they have, and you have the credibility to back your claims, they will join you, provided you deal with them with fairness and transparency, and you deliver. That's important.
Okay, we can take this discussion as like together in this next half an hour. We can do a combined discussion. Maybe Professor Vishwanathan sir can also join us. Devashish, can you introduce him?
Of course. Professor Vishwanathan sir is with us here. Professor Vishwanathan serves as the principal of the School of Business at Amritapuri, with specialized interests in economics of natural resources, management and sustainability. He has a PhD in economics from the Institute for Social and Economic Change from Bangalore, that is from Mysore University. His research and teaching interests relate to economics of natural resources management, agrarian transformations, and rural livelihoods, aspects of technology, institute policies, and governance. In fact, also on climate change impacts on natural resources, environment and agriculture, conservation of biodiversity and ecosystems, sustainable energy policy, globalization and its impacts on agriculture and trade, welfare impacts of trade certifications in India's plantation sector, etc. I invite Professor Vishwanathan to kindly join the discussion here. I request you to kindly start the video, and I invite you, sir. As we before we start the discussions, I think it would be also proper to mention that Professor Vinod Menon is also with us. Professor Vinod Menon is the founding member of the NDMA, Government of India, and adjunct professor here. Has over 34 years of experience in several multidisciplinary public policy areas: disaster management, disaster risk reduction and climate change adaptation, public administration and sustainable development, concern, training needs assessment, design, development, implementation, and evaluation of training programs and development of training curricula and training modules. He's been a member of the High Power Committee, the HPC, on disaster management plan set up by the Government of India in 1999. And he has addressed several international conferences in Kobe, Manila, Beijing, Guatemala, Geneva, New York, Washington, DC, etc. on disaster management, disaster risk reduction, public policy analysis, etc. Currently, Professor Menon is the director of ASIA-TIEMS, the International Emergency Management Society, for the next 3 years, and also of the president of the Radar India for the next 5 years. As I mentioned, also a professor here with us at Amrita Vishwa, adjunct professor here at Amrita Vishwa Vidyapeetham. So there we have quite a roundabout panel, and I invite all the 3 speakers to join us on the audio and video. Again, starting with Dr. Alireza, Dr. Kumar Gaurav, and Crispino Lobo. I request Dr. Alka to lead the questions. There are 2 questions on the Q&A, a few topics which were put on the chat. Dr. Alka, would you like to start with this one? That if there is this one is by Prakash HSM, is the DDG retired of GSI. He wants to know if there is a perception of an impending drought in the coming monsoon with due margin to IMD and SkyMed predictions. Thank you, sir, for the question. Dr. Alka, is there a good time to take this up?
Somehow I can't start my video, but am I audible?
Yes, you are.
Okay, perfect. Now it's working. So, the first question is actually, I think, for Alireza to address, but I don't see him right now in the panelist. Suppose he might have left because it is already late night there. So the question is actually is there a perception of an impending drought in the coming monsoon? To which,
hello?
Yeah, Devashish?
That's fine, ma'am. Please carry on.
Yeah. So right now we don't have him. We will forward this question to him, and hopefully we get replies on. Next question is from some anonymous person. So he's saying that, thank you, sir, for your insightful presentation. My name is Nuru. I'm a PhD scholar here at Amrita University. My research focus on agriculture and sustainable water management. I was wondering if it is possible to get your email address so that I can consult you on certain issues. Amrita is also working on at different villages on different issues. So, Dr. Crispino, your work is completely 100% relevant for us. So we can also try to implement your strategies wherever we can. So it will be helpful if you can help this student or give this student a little time to discuss maybe something he has in person to talk.
Sure, sure.
Thank you. So now just in Professor Vishwanathan, sir?
Say something. Vishwanathan.
Sir, are you there? Yeah, sir is here as well. So
I'm really sorry because when I started video, it got off. Connection lost. Sorry for that. Are you able to hear me now?
Yes, sir.
Yeah. Okay. Sorry for the. My basically 2 questions. One to Dr. Kumar Gaurav about you talked about the damage or the loss of tributaries of Saraswati and other rivers, Himalayan rivers, and we always talk about rivers have died mainly because of anthropogenic factors rather than climate-related factors. But then you also very clearly mentioned that there were climate-related factors also resulting into rivers losing their shape or even their life, etc., became seasonal rivers rather than perennial rivers. So now, what are the kind of anthropogenic interventions, remediations that are happening to revive these rivers? And on the one side, secondly, again, the interlinking of rivers, that project, major project, has it got anything to do with this revival of these rivers, which have lost their tributaries, and bringing them back to the kind of dynamism which they had once? Thank you.
Yeah, so thank you, sir. So I'll take your question. So first is about the human perturbation, human intervention to the system. So if we talk about in case of Saraswati River, that time old ancient Saraswati River, so I don't see it's because of the human perturbation into the system, this river gets lost. The main argument for the loss of Saraswati River is one is the geological control, that says because of the tectonic activities in the Himalaya that leads to avulsion of Satluj River to the westward, westward shift of the Satluj River and eastward shift of the Yamuna River. So this is one is the geological activity, tectonic activity. And the second is some people believe that it's because of the weakening of Indian monsoon. So the monsoon used to be very strong at that point of time. This is what they say, and therefore the river used to generate huge amount of discharge. And this weakening of Indian monsoon has also probably caused the disappearance of this lost Saraswati River. But the main reason I would say is the tectonic control, because the river avulsion is something where river completely moves. I'll give you an example, recent example. If you are aware of 2008 flood in Kosi River, so the Kosi River also it flows through on a alluvial fan that it has deposited. The present position of Kosi River is in the western margin of the fan, western boundary of the fan system, where river flows. So what happens in 2008 because of the avulsion near in the Nepal, just upstream of the Kosi barrage. So river took about 40 to 60 kilometer turn. So you can imagine where the river was. The river was never before. And in one incidence, in one go, river took a 60 kilometer turn, and then it started flowing. So in alluvial system, avulsion is a natural phenomena. This is how river migrates. Okay, so that can be accelerated by the human perturbation. For example, in case of Kosi River, the Kosi River natural tendency of Kosi River is the migrating. It has migrated approximately 200 kilometers in last 200 years that we have reported, that we have mapped. But since Holocene, it is migrating. Now, what we did in 1956, we constructed embankment to jacket the river. What happened to that Kosi River? Yes, you jacket the river. River is no more allowed to migrate. But what happens? There is a sedimentation that has started taking place in the river bed. And because of this sedimentation, river bed degraded. Now in some location, we have mapped already, we have measurements. In some places, river is about 1 meter super elevated than its corresponding floodplain. You can imagine a situation where river is higher elevation at your floodplain, and this leads to increase in the frequency of river migration, which is known as avulsion. And coming to
Thank
your
yeah.
Other
Please.
question, where you said that the river linking project can be used to revive the river which has lost. Yes, that we can think of, but again, that will require a lot of study. So how your subsurface structure is, okay, that is very important for reviving your river. What is the subsurface connection? And then the ecosystem that supports or not. So there are many things that can be considered in reviving such kind of rivers.
Yeah, just one more question to Mr. Lobo. Crispino Lobo. Sir, your talk was quite interesting, and again, you made a lot of impacts in the rural context. Basically, I wanted to bring in the importance of I understand the importance of creating an institutional architecture where there are multiple actors in the rural areas rather than just looking the community from the NGO perspective. So there are several other actors as well. So how do we actually create an institutional architecture by involving these multiple stakeholders? Because you might have got a lot of experience involving these multiple kind of stakeholders, actors in the rural context. So again, given the fact that civil society organizations are also very much into creating better avenues for natural resources replenishment, management, etc., environmental sustainability for that matter. How do you look at this kind of creating an institutional architecture by involving multiple stakeholders? Again, the companies are also there in the rural context, very much operational these days because of their CSR initiatives. So it's basically a kind of a dynamic scenario if you look at any rural context, and Maharashtra is quite known for that kind of a dynamism as well. So how do you see this kind of institutional architecture? It has to be also adopted in other environments as well, in other states in the context of India. Thank you.
Yes, you see, anything dealing with an issue like land and water is a very complex issue with many stakeholders involved in that. So unless you bring all those stakeholders, be they individuals, be they families, be they actors, both in the governance, non-government space, be they private sector, whoever, unless you bring all of them together to contribute or to understand the problem from their perspective, you won't be able to address the challenges in that particular ecological space. So you need to bring in all the various actors. Now, the institutions exist. I mean, at the village level, there's the Gram Panchayat. You can even now set up a village development committee or a watershed committee or a water users association, whatever you want. And the law permits them to become part of the institutional governance structure at the village level, because the amendments have been made to the Panchayat Act, etc. Government is there. It's already there and working in these villages. There are NGOs, there are companies, there are the political class. You need to bring them all on board. Otherwise, it cannot be done. See, because land and water affects the fortunes as well as the interest of all these parties. Once it happens, then you can have transformation. Because you must keep in mind the real nub of the matter is not when you're doing the work. That's the simplest part of it. It's post-recovery. When the work is done, it's its management, continuity, and sustainability of an activity. And for that, then, you need to have priorly a consensus of mind, a consensus of what is being done and why, and an ownership or buy-in into that effort, because only then it will continue after the project is over. See, so there is already an institutional structure. The point is to be able to bring it together, create the dynamics of thought, perspective, consensus, and will, and to weave together the various resources into doing what has to be done.
Well, Dr. Lobo, may I just intervene here? Of course, these are very nicely thought out wish lists. I think I fully agree with you. All of us will agree that we need to involve all kinds of stakeholders. But the things which we are trying to take away from your presentation is how best to do it, because we are as part of the C20 group arrangements of all these talks and these roundtables is to develop some policy document wherein we can recommend some model practice which has been really successful, the case studies that you have been building, and which can be promoted the world over to be adopted by other similarly placed countries like ours. So we will be really interested in knowing more about the modular approach, how we started and how you did it, and whether in the present day times, whether it is still applicable. That is one. Other thing is, sir, you are, I think, your work of your CSO is centered more around rural community, which of course is the major use of land and water, particularly agriculture related activities. But I think our concern is also for the urban domestic water requirements in many of the cities, particularly close to the aridity affected areas. For example, in Rajasthan, there is a huge acute shortage of even drinking water. And whatever water is provided or extracted from the groundwater sources, how do we really take care of the wastewater management? How best to recycle it and conserve it? Maybe your experiences can really enrich us more on this. Thank you.
Yes, thank you. Thank you for that. So this is not new. What I showed you has been going on in India for the last 30, 40 years. And the government has adopted watershed development as a strategy for rural development, probably over the last 20, 25, 30 years already. And the recent new policy published by the NRA, that's National Rainfed Area Authority, also has talked about what I've said and brought together many years of experience from various sectors into how to upscale watershed development across the country while keeping people, rather the community as well as nature in focus. That's a new addition to this policy. That's number one. Number two, we have a lot of material and it can happily make it available to you. You might be pleased to know that we have already an MOU with your university, and we can in that certainly share and partner with you in the formulation of a policy document. And thirdly, with regard to your question about urban water issues, all except for groundwater, where you have wells in the village, in the town itself, all water for urban areas come from rural catchments. The dams are in rural areas and they harvest the rainwater falling there. And these are then conveyed by gravity systems or by pumps to the towns. So if we don't address that water catchment rehabilitation, you're not going to be increasing the water availability to towns, number one. Number two, unless urbanites take up water harvesting either through rooftops, through making their roads less concrete with more porosity, unless you recharge groundwater, because 60% of, by and large, between 50 to 60% of water in urban areas comes from wells in those urban areas, then you need to recharge that groundwater, which is within their hands. So, and third, and which is far more important than all this, is they have very simple things which they don't do, unfortunately, and that is change their behavior. Like, for instance, when they're brushing their teeth in the morning, not to leave the tap running while they're still, brushing their teeth. 40% of water in urban areas is wasted because of leaking conveyance system. The pipes are leaking, right? The way you just by improving the way we use water, will save as much as 40%. So behavior changes, and we need to really change and nudge people to change their attitude towards water. India is heading, even Niti Aayog has said that, is heading for a water, cataclysm. It's going to be a huge issue, and action has to be taken now.
Yeah, that's the question, which is again the same, bringing back to the question I asked, because it's like human consciousness has to grow in a level that you are wasting the resource, which is shared by all of us. I mean, you are pointing towards urban population who use brush and keep the tap open. Unfortunately, I have seen a village in Haryana. There they have, because now our government is providing tap water to villagers too, and they are like, okay, they just don't want their to open and close the tap. They keep the nozzle up, tap, what do you call, the nozzle with which you close it. They just remove it and let the water flow from the sink, because every time they have to come and get their bucket, maybe this little laziness, or I don't know what, the level of connection to the nature, to the resources is still somehow missing in our community. Mm-hmm. In the rural too. So the rural community who is really working with this soil and water, they are not concerned about it, which is unfortunate. And I don't know how to convince the people at a larger scale that this is common shared resource which all of us are responsible. So how do you approach this? This was my question at that time. Again, I'm coming back
See,
to it.
it's like this. It's like this. The amount of water that each person in Pune is provided for by the municipality is something like 255 liters per day. All right. If a ruralite gets 50 liters per day, is considered a lucky person. Where do you think the responsibility lies more?
Yeah, see, I mean, okay, I understand your point because they have 24/7 availability. Villages will have maybe 1 hour of time when they get in morning and the evening. But the unfortunate part is because they are not using water here just as a tap water, they are also using water in their field. Now, if they are not sensitive to it, I know because I have some background from agriculture. I know people just let them because they have right now the electricity is there. They'll just put their pump on and let groundwater keep flowing. Maybe they don't have enough number of people to distribute it in the field. Then water will just make its own channel and drain it into some common, local river. So this kind of convincing people that it's not that because you don't have to pay the bill, because water is coming for free, you don't waste it. This kind of convincing the community, raising their awareness and consciousness is challenging. And like you were talking about water budgeting and at a village scale level. So I was wondering, was it at like at panchayat level? You have seen it or people do it, that they kind of see, okay, these are the fields, they have these kind of crops, so you are allowed to use this much of hours of groundwater for this, and otherwise you are taxed by so and so means. So even the panchayat has a power to control some kind of water consumption habit, or I don't know, something which is really by enforcement or by convincing, somehow people change their habit or the way they use it. If you have seen or you have done something in that regard.
Yeah, I've shared with you several aspects of how we encourage people to manage the demand or the use of water, including crop water budgeting, adoption of water efficient technologies in terms of the water governance standard, aquifer management, which basically nudge people towards behavioral change and attitudinal change. These must become more and more the practice, but it's a process, it takes time.
Yeah, this adoption of technology, Dr. Lobo, and I think other panelists will agree that it requires a lot of financial inputs. I mean, you cannot leave it alone to the community involvement. There has to be some support from the government and other institutions wherein this technology transfer is facilitated. What do you say on that? Do you have any examples of such interventions?
Yes, for instance, there is a lot of government subsidy already for many of these technologies, like, for instance, drip irrigation. It ranges from 50 to 80%, depending from state to state. Subsidy. Polyhouses, 50 to 25, for 25 to 50%. So there's a lot of inputs. One can argue it may not be enough given the scale of the problem, but it's quite substantial.
Okay, now can
sir, just on that note, sir, I just wanted to highlight one more thing. I think there was also a discussion when I met Dr. Marcella during the Sikkim event. She has also been highlighting about the problem of the overusage of drip irrigation systems and all, overdrawal of water, withdrawal of water from the groundwater, which is basically induced by the subsidy technology, basically. So farmers are actually not understanding the social responsibility because this technology has come for water saving. But instead, farmers are actually using more and more water. So the purpose of water saving is not met through the technology. So this is where we actually need more the behavioral kind of changes to happen, as other members also has highlighted. So maybe you can, how did you actually overcome this problem? This is basically what we wanted to know. This convincing farmers about, because there is a technology, you have to use it very responsibly. So this is basically the kind of question that we were actually trying to understand from your experience. Thank you.
Yeah, so basically, as in all things human, it's a question of establishing relationships and building on that. So you need to reach out to these communities, you need to engage, undertake a lot of awareness raising, discuss and identify with them what is the problem they're facing. In the case of water scarce villages I'm talking of, and how do you solve that? Now, in areas where there's surplus water, maybe in Haryana, Punjab, etc., then the solution is not to change the behavior from the way you use for dryland areas. You know, if you get free electricity and there's no tax on water use, then you're incentivizing behavior that is careless. So you need to put in place. Is people will only change their behavior if they pay a price for it. You see, right. Or a cost to it. And unless the country or the community is willing to pay that price, there will be no change.
I can see, Gaurav, you wanted to add something?
Yeah, just a small question, and that I would say I'll share my experience with Lobo. Thanks for nice presentation, Lobo. And I like your idea of water budgeting. I remember 3 years ago, I was discussing this concept with one of my students. I was saying him, can we develop such kind of technology by which we give this information to the farmers, how much water you are using, how much water is available in your aquifer, and how much, if you are doing different kind of irrigation so how much water you are losing as a evaporation and by other medium. I'm very happy to see that you are practicing it. So this is one thing. Other thing, just I wanted to add one thing, because we were in the discussion how to use water efficiently in rural area. I do agree with Alka that these days people are doing, they are losing water because they are getting water from the government. They don't have sense. But because I come from a village background, and if I recall my emotion with the water, so I have seen a transition from dug well to the bore well and now to the submersible. And that had impacted heavily to the groundwater availability and also to the rivers. The river used to be perennial, now there is no water in the river. And people are very sensitive about these issues. They understand these things. But the problem is, one thing, availability. If you have a dustbin, people will use it. We cannot blame it. You are throwing stuff on the road for the sake because you don't have dustbin. The one thing, if we can somehow educate them, and yeah, because they are, as you rightly said, they're ready to understand. So once we can take this kind of initiative that, okay, this water is coming from, it's not, though government is giving, but it's not free of cost, because you will have to pay in next 10 years, 15 years. You have seen the trend of water availability in the system, in your village. In a similar way, water is not for forever. You may lose. So I think that kind of understanding, that kind of knowledge, if we can propagate to the stakeholder and to the village farmers, that would be. And the other thing, coming to the paddy. So paddy, culturally, we used to grow only in the region where you had excess water during the rainfall. And to grow paddy, we were not extracting water from the groundwater. Now what happens, because of the spatial shift in the paddy crop, now people have started producing paddy where there is no much surface water available. And therefore, to grow that, they are extracting water. So also this kind of understanding, what are the infrastructure, what is the ecosystem that you have to grow a particular kind of crops, that also needs to be explained them properly. This is what I think.
Yeah, I completely agree. Professor Vinod sir, would you like to say a few words?
Thank you. I feel that these topics are extremely important, and the issues which are being discussed are also extremely important. I felt that the discussion on drought monitoring as well as on drought management, both by Dr. Ali Reza and also by Mr. Crispino Lobo, actually suggest the need for really looking at the solutions. What water has been doing is important because we have seen that India has been facing drought in more than half the number of districts in the country. And according to one of the affidavits submitted to the Supreme Court, it mentioned that almost 50% of the districts in the country were facing drought at, I think it was a few years ago. But it is likely to worsen in the coming years if we are not actually taking adequate preparedness and also remedial measures. And so these suggestions are important, and so we need to really look at that. I was just wondering whether only looking at recharging groundwater aquifers would actually be providing the solution, because there is also a large area where surface water is actually staying, and then we also have lakes and rivers and water bodies and wetlands where there is also a lot of evapotranspiration happening, which is also leading to further rains. So there is a need for some kind of a balance between the surface water as well as groundwater recharging, and also management of water through appropriate water budgeting measures. So we need to really look at that as a priority. Thank you.
Thank you, sir. I mean, we are getting like 10 minutes extra. I'll be reading a few more comments which are there in the question answer session. So, Mr. Krishnamurthy from DISA Anantapur said that thank you for the speaker. Thank you all for the speakers for their valuable information. Water conservation and environmental resilience is a continuous process. There'll not be an end, but unfortunately, our government of India slowly withdrawing the watershed activities. It is prime responsibility of the government and other stakeholders. So kindly make it mandate in this policy. Thanking you. Sir, I don't know, maybe your experience says so, but what I am seeing these days, at least from my little experience, I have seen government, I mean, at least in my village in Madhya Pradesh, Government of India has initiated many policies, and there are significant amount of change lately we observed. Be the construction of a small pond, lake kind of structure, like also Dr. Crispino Lobo talked about, some ridge area or the hill area, ducts, I don't know what is it called, trenching. I have seen myself, and which is kind of, I have never seen these kind of changes in village before. So maybe your experience is different, but definitely we need more intervention. We need not only government, also people contribution towards it. And like Gaurav talked about the historical movement of river from one drainage pattern to another. Not only back then in history, maybe nature played major role, but now we have power to overtake nature in a way that we may change the drainage pattern, and we may change it positively or negatively. So learning from history, we need to see that we don't create another Saraswati, or if we can bring it back, that will be our
that will be a question to Dr. Gaurav. Can we really revive and rejuvenate Saraswati, at least the part which used to flow in India? See, Ghaggar River is still there, although it's not flowing as a perennial one. But based on the various studies, including yours, is it really feasible to revive? And that's what I think Government of India presently is also interested in. And in fact, I can also share there's an idea of developing geotourism all along the routes wherever these archaeological finds are there. So these can also be developed into the tourist destinations, provided we have a regular flow of the revived Saraswati. So what's your take on that, please?
So at this point, sir, scientifically, I cannot say, but yes, I can think of such kind of things happening, because the main problem is to revive such kind of river, you need that kind of flux to flow. Okay. And that if you,
maybe interlinking of the rivers, maybe surplus water from Yamuna can still be diverted.
Yeah, so if that can be done, that is quite possible. But you need, for example, Yamuna at Yamuna Nagar. Okay, the discharge is hardly, because we are distributing water to Haryana, Uttar Pradesh, and all those things. So there is very less water available. So to have a flow, perennial flow in Saraswati River, the very first thing is we must ensure that the input flux must be, minimum input flux must be maintained. So yeah, that can be, yeah, that's a very important point that can be think of in more scientific way. And
you have any data, sir? You have any data on what could be the minimum influx, what quantity is really needed, so that more systematic studies can be taken up on that.
So, sir, the discharge value I have given you, that it corresponds to the average quantity, average annual. So that is responsible for forming a channel. Means if you in alluvial system, your river is wide. So that width corresponds to what? That width corresponds to a discharge that has carved that width. Okay, so that is 3000. Okay, so that kind of discharge would be, I would say, is would be required.
No, but here, Dr. Gaurav, about paleochannels, my own experience is that they are of different ages. Within the quaternary period, there are a lot of superimposition of various paleochannels. Yes. So it's not, really a direct correlation between the width of the paleochannels and the width of the particular time when the river was flowing. It's a succession of various different channels. Right? Yeah. So what would be the real optimum availability of water to make a river flow in such conditions? If there is some work which is taken up, I think that will be really very, very interesting.
I think it's a very important research question, and I'll start working on that, because the meaning, because that is very important in a way of river linking, and there are many different aspects that one should consider.
Yeah, the Markanda stream, for example, Markanda. Yeah, that can also be diverted to this, and I think there is a need to do some more research work on this. Thank you very much for sharing all these views with us.
Thank you.
Thank you everyone for joining. I mean, it was really good discussion, and I feel like continuing, but we are overshooting the time, and I am sure all of you are also busy with many other things. So I'm handing over the floor to Devashish. Can we just wind up the session? Okay, so it seems he's not there. So would you like to say?
No, thank you very much, all the speakers. We have had some very insightful and very, very interesting presentations and topics. And we will be again sitting on the things which are delivered, which are recorded, and maybe try to extract a policy document, some major recommendations which should go regarding the role of the CSOs vis-a-vis the government interventions, and how best to change the behavioral aspects of the communities, so that water budgeting is also involved, and we have better water efficiency, use of water in a more sustainable manner. So thank you once again, all of you. Really grateful to you for your presentations, and we look forward to much more interactions with you in subsequent times. Thank you very much once again.
Thank you.